Well, good afternoon. I'm Dave Mahan, the Chief Security Officer at CenturyLink, and I would like to introduce our next presenter. Justin McElhattan has been with the Industrial Scientific Corporation since 1998, serving in various roles before becoming President and Chief Executive Officer in 2010. In this role, he is responsible for leading the company toward achieving its mission of preserving human life on, above, and below the earth. Prior to Industrial Scientific, he worked in the industrial safety distribution industry. Justin earned his Bachelor of Science in Environmental Resource Management from Penn State and also holds an MBA from Tepper School of Business at Carnegie Mellon University. Justin.
Thanks. Good afternoon, everybody. I appreciate the opportunity to talk a little bit about the work we're doing in Industrial Scientific and how we're applying data to a pretty tricky problem, people getting killed at work. I want to give you a little bit of background on our company, Industrial Scientific, if you don't know about the company. We were founded in 1985, and we got our start in coal mining. We were founded as a research division inside of a large mining machinery company called National Mine, headquartered in the steel building. And the assignment given to a small group of folks was find ways to detect gases better. Been a number of large coal mine explosions, and at the time there needed to be some improvements in technology for detecting methane and other hazardous gases. And that's really where we got started. We went independent in 1985 with 30 people out in Oakdale, Pennsylvania. And one of the little claims to fame of Industrial Scientific is that we were very much responsible, one of the major forces for flame safety lamps going away. If you've ever seen flame safety lamps that they would carry in mines, if the flame goes up, you've got methane. If it goes down, you don't have enough oxygen. And so for years, that's how people detected gases in mining. We were the first company to make a handheld digital oxygen and combustible gas detector that people could actually carry around and get an accurate reading on gases. And so that's really where the company got its start. Today, Industrial Scientific, we have 750 employees, and we're serving a very broad range of industries that I'll talk about. We're headquartered here in Pittsburgh. A couple of manufacturing plants, our largest plant here in Pittsburgh, one in Shanghai where we make sensors, and sales and service locations in 23 countries. Just to give you some visuals on the work we do, or to quickly just give you a snapshot of the company and maybe how to think about the company. Our core business, as I said, is gas detection. We deliver gas detection as a service. We've gone through an evolution over the last decade that I'm gonna talk about. We've partnered with Cisco and Accenture in doing some very interesting work around connecting industrial workers and providing visibility and accountability into people in potentially dangerous workplaces. And we have a lot of energy going into sensor research. We have a couple new ventures, and I'm going to touch on these as well. One called Predictive Solutions, an acquisition we made about 7 years ago. That's looking into data and analytics applied to safety. And last year we spun out a group called StartBot to do investings to accelerate robotic technology towards the end of eliminating death on the job. So kind of how to think about the company. On the gas detection side, we get involved in some pretty interesting scenarios. This was right after 9/11. You can see the rescue worker on the left wearing one of our instruments here. We are on the International Space Station. We're one of the pieces of equipment. It was remarkable in the movie Gravity. There's a scene with Sandra Bullock, and our products are very visible there. We are used by fire departments in hazmat response. If you call the fire department because your carbon monoxide detector is going into alarm, they're likely to have one of our products to come in and check at a very precise level, an accurate level, the amount of carbon monoxide in your home. We're in the oil and gas. We do a lot in oil and gas. I have this picture. This is from the far north slope of Alaska, where it's minus 40 degrees, and people are wearing our instruments out in the field. And then we get involved in some interesting applications around SWAT and police response for meth lab raids. The gas constituents in a meth lab are very dangerous, and we make equipment that can be used to detect that. So a little bit of pictures of what we do, just to give you a kind of a physical sense of the products that we manufacture. We have a vision that we talk about and that we cue everything in the company around. And we say we're dedicating our careers to eliminating death on the job in this century. There are about 5,000 people killed each year in workplace accidents in the U.S. Globally, that number is about 350,000. And it's extremely frustrating when we're involved in investigations afterwards, which we sometimes are, to look back on those dots that we could have connected before there was an explosion or before somebody was poisoned. And so we're putting a big emphasis into this vision. And that's what we think we were put on this earth to do, was to be a catalyst in industry to help eliminate death on the job. Pittsburgh has had a very central role in the workplace safety movement. And some of you have maybe heard about whoops, I'm going backwards here. Anyways, the picture's not coming up, but Pittsburgh was the site where a woman named Crystal Eastman came down here from Boston in 1910. She was a lawyer from Boston, a young woman, and she started a research project to look into the effects of workplace injuries and fatalities. And it was called the Pittsburgh Survey. It was really one of the foundational pieces of work around workplace safety, and a bunch of things happened around 1910. The Pittsburgh Survey was published, National Safety Council was founded, Upton Sinclair's work, The Jungle, was published at that time, and I think the consciousness that we should stop killing people at work was kind of, was where, there was this movement that kind of started at that point. And so when you look back on those times and what was going on, she cites this great example. And I think this picture will come up. She talks about railroad connectors in the book. And she uses this as a great example of what we need to be doing. That prior to 1893, most railcar connectors needed to be physically pinned. They weren't automatically locking. And after there was legislation that came out and technology that came out that allowed rail cars to automatically couple when they touched each other. And she cites this and shows a picture here where she says, look, there was legislation and technology combined, and look what happens to the fatality rate in coupling accidents. It goes away. It goes down to virtually nothing. And so she says, let's go do a whole bunch of this. And so over the last 100 years, when you look at the work that's been done, there's been, that graphic's not showing up either. Anyways, there's been a huge improvement over the last 100 years. When you look at productivity rates, when you look at fatality rates, we've made huge progress as a society. But when you look at the last 20 years, we've really leveled off. And particularly when you overlay a trailing GDP growth chart on it, you can start to look at the correlation of economic activity with workplace fatalities, and it's hard to pat ourselves on the back and say we're making a big impact in this, at least in the U.S. and in some countries, the rates are actually increasing. So this is a problem, and this is what we're dedicating our careers to fixing. And we believe in Industrial Scientific that the next big inflection point, the thing that will help drive an inflection point in this, is data and information. And I want to talk a little bit about how we're doing that and how we're applying data to this problem of people getting killed at work. If you're in the safety industry, you have a prescription for stopping people getting killed at work. It's called the hierarchy of hazard controls. Has anybody heard of the hierarchy of hazard controls? This is just a great little tool, and basically what you do is you identify all the hazards in your workplace, right? What are all the hazards you have? And then you simply eliminate those hazards, right? Well, you can't eliminate all hazards in the workplace. So then you substitute things for that, something less hazardous. If you can't do that, then you apply controls around it. You apply engineering controls or administrative controls or behavioral controls. And if none of that works, you go down into this world of personal protective equipment. You put a hard hat on somebody, or you put protective gear on somebody, or you put a gas detector on somebody. And we live in this world of personal protective equipment. And, you know, the gas detectors today, an electronic gas detector that 30, 40 years ago we were getting so excited about because it's digital and things like that, you know, when you look back at how people used to, and in this case still are detecting gases, using a chicken in a cage, and watching the bird to see if, you know, to see if it dies, that's when you leave the area. They're not much different. Most of our customers today they're wearing digital equipment that gives some indication, and that's where it ends. And so this has been something that we've been wrestling with. How do we prevent people from getting killed at work, and how can we go beyond just offering electronic chicken to our customers? And so 11 years ago, we launched a program called iNet. We grew up as a very traditional manufacturing company. We vertically integrated. We made the sensors that went into our instruments that we then sold and supported. And we began in 2000. We launched in 1999 the development project, and commercially launched in 2003 iNet. And what iNet simply is we sell gas detectors to our customers bundled with an analytics package, data package, and services. We sell it as a subscription. You pay by the month on how many pieces of equipment you need, and it just simplifies the whole management program of gas detection. The equipment is connected to the web, and we're monitoring 150,000 pieces of equipment in 28 countries here in Pittsburgh. And when a service is needed on that equipment, we're able to deliver a replacement piece of equipment. Over the years, we've collected a lot of data, 280 billion data log readings, a lot of alarm events, a lot of instruments on the platform across a wide variety of areas. And going back to just give an example of where, and this is not rocket science stuff, this is just using data that you have. Of a very typical story of ways that we've been able to use the data that we're collecting to help keep customers safe, more safe. Is in a case here where we presented one of our customers some data. They have about 1,100 instruments spread across 7 countries. And we said, hey, you've got 1,000 employees. Last year you had 7,000 gas alarms. And they said, well, that sounds about right. That's about 7 alarms per person. We said, well, when you go one level deeper, 998 of your people had an average of about 6, and 2 of your people had 350. And the safety person literally got up and walked out of the room, because this is so typical of the kind of information that you find out after there's been an explosion. And when you read a lot of the newspaper reports on things like the Upper Big Branch explosion in West Virginia back in 2010, and you hear this these conversations. We all knew we had elevated methane, and the levels of gas were 2 to 3 times what they were supposed to be. This is stuff that a lot of people in they know this, but we're not able to put numbers and analytics to it and then take action. In this case, we were able to take a piece of personal protective equipment, make it a little bit smart, connect the data up, and deliver insight that helped them move from just giving those 2 people personal protective equipment that in that case required behavioral controls, and they were able to address it through that. So, in this march to eliminate death on the job, when you're starting from personal protective equipment, we want to try to find ways that we can anticipate hazards before there's an incident. I'm going to give an example. I talked about predictive solutions at the beginning, and very simply what we do with predictive solutions is that we provide a safety observation system. Whether it's a mobile handheld or some other device, we're able to go out and do safety inspections, most of which, by the way, today are done by hand on with paper and pencil, and they go into some file cabinet. We do those inspections. It's digital. It's uploaded to the cloud. And we've collected a lot of observations, 180 million observations, 5 million unsafe observations. 60,000 inspectors, a whole bunch of safety incidents. And just simply digitizing those safety observations has been remarkable. We've been able to deliver basic analytics on a lot of those things and given companies teeth now to put into practice to drive behaviors in their company, good behaviors in their company that keep people safe. We have one customer, I like to talk about this example, that has, they had some bad safety incidents over the years, and they needed to make a significant culture change. And it wasn't just enough for the CEO to be kind of pounding on the table about it. They wanted to put some teeth behind it. They wanted to put some metrics behind it and some measurements behind it. But the measurements that they had, the things they were talking about was, we want to foster understanding. We want our people to be brave. We want our people to have caring conversations and hold each other accountable. How do you do that? They used the inspection platform as that. As a proxy for measuring being brave, they looked at the number of at-risk observations per audit that they were seeing. How brave, if I can I walk up to a senior executive who doesn't have his safety glasses on and do an unsafe observation on that? So they looked at that. They looked at the number of audits as carrying conversations. It's the last speaker was talking about crowdsourcing. That's fundamentally what it is. A whole bunch of eyeballs in terms of looking at how safe an operation is. And in understanding, they look at time to close of open safety issues. So now you're taking these kind of difficult to measure things and giving some backbone to that where people can measure it. In the last couple of years, by the way, they've corrected 312,000 at-risk observations. And so I think when you look at the ability to centralize data, know where your top risks are, have people looking at it and making it easier, it's remarkable the kind of impact that you can have. We've also kind of gone one step further and said, hey, can we predict and prevent accidents? And so we've partnered with the Language Technology Institute at Carnegie Mellon. We have in-house analytics experts, and we're looking at models. We call it the red flag model, where we're using, where we're running models against the data, algorithms against the data that give us a little nudge and a red flag when we think that an operation is likely to have an incident in the next 30 days. And we're measuring kind of the same thing on that. We're looking at engagement, diversity of inspectors, the ability to seek truth, speak truth, accountability, and quality. We measure the quality of inspections in a number of different ways, but are people doing 100% safe inspections on Friday afternoon at 4? You can tell a lot by those kind of things. I like to show this picture to give people a visual. I asked my 12-year-old son if his bed was made, and he said yes, it was, and I went up and that's what it looked like. Is the bed technically made? Yes. But it isn't really, that's not a high quality bed making project there. So anyways, we're able to use these things and provide some measurement behind some oftentimes hard to measure dynamics in a business. I want to summarize with this picture. I get a lot of inspiration out of this picture. And does anybody know what this is, by the way? This is a picture from the cholera epidemic in London in 1855. And we oftentimes think about big data and everything, and at the end of the day, it has to be effective. John Snow was an epidemiologist and was brought in to help out with a cholera epidemic that was killing many people in London. And he was able to map out some data in a very simple way. And what you see with the yellow circle is a pump. The little ticks behind it are the number of deaths from cholera that occurred. People had struggled with this problem for ages, and then they finally were able to look at this, the data presented in something that was digestible, and immediately take the handle off the pump and save a number of lives. And I think this is a great kind of analogy to what we're doing today on a scale that is much larger. So I want to thanks for your attention. I'll be available if you guys have any questions, and appreciate the Technology Council for putting this on. So thank you.